Section 44C, Activity and Special Angles and Coordinates. In this lesson, you will use the video as well as the things that you learned in the video to complete the notes packet. Goals of the lesson. In this lesson, you will review special right triangles and explore the trigonometric ratios with special right triangles. Explore and learn how to find all 6 trigonometric functions of special angles without a calculator. In this warm-up, we will review our special right triangles. You know from geometry that with a 45, 45, 90 triangle, the two sides are x, x, and x root 2. With a 30, 60, 90 triangle, the short, which is opposite the 30 degrees, is x. The side opposite the 60 is x root 3, and the side opposite the 90 is 2x. We can use this idea to find the 6 trigonometric ratios for 30 degrees. So if we do the sine of 30 degrees, we know that sine is opposite over hypotenuse. So sine of 30 degrees is going to be x over 2x, which reduces to 1/2. Cosecant of 30 degrees is the reciprocal of that. So since sine is 1/2, cosecant is 2 over 1. Cosine of 30 degrees is adjacent, which in this case is x root 3, divided by hypotenuse, which is 2x. When we reduce, the x's cancel, and we have root 3 over 2. Secant of 30 degrees is the reciprocal of cosine, so it becomes 2 over root 3. Because we have a radical in the denominator, we must rationalize. So we're going to multiply by root 3 over root 3. And our final answer for secant of 30 degrees is 2 root 3 over 3. The last 2 trig ratios are tangent. Tangent of 30 degrees is opposite over adjacent. So in this case, opposite over adjacent. X over x root 3. When you cancel out the x's, you get 1 over root 3. Once again, we must rationalize. So we're going to multiply by root 3 over root 3, which simplifies to root 3 over 3. Now cotangent is the reciprocal of tangent. So the cotangent of 30 degrees, let's take this one to make our lives a little easier when we do the reciprocals, would just be root 3 over 1. That's already rationalized. So the cotangent of 30 degrees is just root 3. Now pause the video and do the other 2 warm-ups on your own. The next slide will be the answers to the warm-up. Here are the answers to the warm-up. Note, for the ratios that had radicals in the denominator, I have given both the rationalized and the not rationalized denominators. You should always rationalize something, but I want you to see what it was not rationalized so you can sort of see the steps in the process. The following chart is information you will need to know. Throughout the activity, I will lead you through the process of understanding what is in this chart, and by the end of the activity and upcoming classes, you should be able to recreate this chart. Everything that we've been doing has been working our way up to this lesson. We've been finding angles. We know that on a unit circle, cosine is x and sine is y. It does not matter where on the unit circle you are, cosine of theta is x and sine of theta is y. So every angle is associated with a set of coordinate points. The reason we learned about reference angles is reference angles have the same coordinate points but vary in signs, SIGN. As I stated before, if you are part of the same family, so that family means you have all 30-degree reference angles. In this slide, we're going to deal with 30-degree reference angles. What you discover is anything that's part of the 30-degree family has the same coordinates but different signs. So let's look in the first quadrant. In the first quadrant, we have x comma y represented by cosine of 30 degrees, comma, sine of 30 degrees. If you go back to the warm-up on your notes, you'll notice that the cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1/2. Those distances are represented by their coordinates. So cosine is x, so this distance right here is root 3 over 2, and sine is y, so the distance right here, which is our vertical distance, is 1/2. We can put this into practice on our unit circle. Here is all of our 30-degree reference angles. If we find the actual angles in radians, it's fairly straightforward because we know a 30-degree reference angle in radians is pi over 6. Anything over 6 that's reduced all the way is a 30-degree reference angle. So this is pi over 6. Now, this box represents 0 or 2 pi, and when our denominator is 6, we represent 0 or 2 pi with a denominator of 6. So we have 12 pi over 6. Pi, also keeping our denominator, is going to be 6 pi over 6. When we do this, and we know that we're dealing with 30-degree reference angles, it is fairly straightforward to find all the other radian measures. Since this is pi, the angle that's slightly less than pi is 5 pi over 6. That represents the 30-degree reference angle in radians in the second quadrant. If we want to go a little bit more than 6 pi over 6, that's 7 pi over 6, which is our radian measure in the third quadrant. In the fourth quadrant, we go 1 less than 2 pi. So 1 less than 12 pi over 6 is 11 pi over 6. Now degrees, we have to use what we learned with reference angles. So this will be 30 degrees because it's in the first quadrant. Now we know that this is 180 degrees. So 180 degrees minus 30 is 150 degrees. 30 degrees plus 180 is 210 degrees. And then 360 minus 30 degrees is 330 degrees. So now what we have done is filled in our 30-degree family with degrees in radians. But what we need to do is our coordinates. So as I stated in the last slide, we know that the x value is root 3 over 2, and the y value is 1/2. In the first quadrant, x and y are both positive, so root 3 over 2, comma, 1/2 is our coordinate. Well, we keep those same coordinates and we move to the second quadrant. But what happens in the second quadrant is x is negative. It still has the length of negative root 3 over 2, but its sign is negative. Now y, as you see, is still 1/2, and it's also positive because the y value in the second quadrant is positive. So our coordinate in the second quadrant for a 30-degree reference angle is negative root 3 over 2, comma, 1/2. In the third quadrant, we still have the length root 3 over 2, and it's still negative. And we still have the length 1/2, but it's going down, so it's also negative. So in the third quadrant, our coordinate is negative root 3 over 2, comma, negative 1/2. In our last quadrant, the x value, which is root 3 over 2, is positive, but our y value, which is negative, is negative 1/2. So the coordinate in the fourth quadrant is root 3 over 2, comma, negative 1/2. These are all the coordinate values for the 30-degree family, and these are all the sine and cosine values for their respective angles. The information below gives us sine and cosine by just looking at the coordinates, but the tangent you need to do a little bit of work. So as we recall, the tangent of an angle is y over x. So if you take your y and x coordinates and you divide them, you'll get the tangent. So in the first coordinate, we need to take 1/2 and divide it by root 3 over 2. Well, 1/2 divided by root 3 over 2 is 1/2 times 2 over root 3. The 2's cancel, and we're left with 1 over root 3. But we need to rationalize, so we have root 3 over root 3, which simplifies to root 3 over 3. So the tangent of 30 degrees is root 3 over 3, which you can see from the warm-up. Now we can use the idea of sines and fill in the tangent for the remaining angles. So the tangent of 5 pi over 6, or 150 degrees, is going to be negative root 3 over 3. We know it's negative because in the second quadrant, our y value is positive, but our x value is negative. And when you do y divided by x and one term is negative, the whole thing is negative. In the third quadrant, we still have root 3 over 3. So the tangent of 7 pi over 6 is root 3 over 3. But it's positive because when you take y divided by x and they're both negative, two negatives become a positive, so the tangent is positive. In the fourth quadrant, we have the tangent of 11 pi over 6, which is negative root 3 over 3. It's negative because the y value is negative, but the x value is positive. Another way you can think about it is we know that all students take calculus. In the first quadrant, everything's positive, including tangent. In the second quadrant, sine is positive, which means tangent and cosine are both negative. In the third quadrant, tangent is positive, and sine and cosine are negative. In the fourth quadrant, cosine is positive, which means tangent and sine are both negative. Now it's your turn. Fill in the activity packet for 60 degrees. Use your peers in class and fill in the notes. I know you can do this. Skip the practice problems at first and fill in the activity packet for 45 degrees and the quadrangles. Feel free to use the post-it notes, but try to do it by talking to your peers first. Once you have finished all of the circles, go back to the practice problems. The next slide explains how to do some of the practice problems without a calculator. Note, 45 degrees, all the radians values will have a denominator of 4. So pi over 4 equals 45 degrees, and all of the denominators will be over 4. With 60 degrees, it's pi over 3. All the denominators will be over 3. So you can use it with 30 degrees, it was 6. You can use what you filled in for 30 degrees to do both 60 degrees and 45 degrees. Now, how do you use what we just learned to actually solve problems? Well, the first thing you need to do is you need to actually graph your angle. So because it's over 6, we know this is a 30-degree reference angle. Because 30 degrees is 6 pi over 6 for pi and 12 pi over 6 for 2 pi. 11 pi over 6 is 1 less than 12 pi over 6. So I know I'm a 30-degree reference angle right here. This is where I'm located. Now I need to figure out this coordinate. This is the part where you have to remember a little bit of your geometry. For 30 degrees and 60 degrees, the coordinates that you're going to use are root 3 over 2 and 1/2. Root 3 over 2 is always the longer side, and 1/2 is always the shorter side. The reason why we know this is because root 3, which is in the numerator, is bigger than 1. Since root 3 is bigger than 1, we know that root 3 has to be longer. So when we draw our picture, we know that 30 degrees is relatively small. Here's our 30-degree reference angle. We know because this is longer in length that this is going to be root 3 over 2. The y value, which is smaller in length, is going to be 1/2. Since we're in the fourth quadrant, our x value is positive. So we have positive root 3 over 2, and our y value is negative because the y value in the fourth quadrant is negative. So our y value is negative 1/2. But now we actually have to answer the question. The question was sine. We know from the first things we did with trig that sine is y. So since this is sine of 11 pi over 6, and the y value at 11 pi over 6 is negative 1/2, the sine of 11 pi over 6 is negative 1/2. To find the tangent of 2 pi over 3, we must first graph 2 pi over 3. Now because it is over 3, we know it's a 60-degree reference angle, which means pi is going to be 3 pi over 3, and 2 pi will be 6 pi over 3. Because it's 2, which is 1 less than 3, we know it's a 60-degree reference angle in the second quadrant. So here is our 60 degrees. Here is our 2 pi over 3. So we know that from before that root 3 over 2 is long and 1/2 is short. So we know that this distance, which is short, has to be 1/2. And since the x direction is negative, it's going to be negative 1/2. Now, the y value, which is long, is going to be root 3 over 2. So at 2 pi over 3, the coordinate is negative 1/2, comma, root 3 over 2. Now, x is cosine and y is sine, but tangent is y divided by x. So now we must take our root 3 over 2, which is our y, and divide it by our negative 1/2. So root 3 over 2, now we have to multiply because it's division, multiply by negative 2 over 1. Our 2's cancel, and we have root 3 times negative 1, which is negative root 3. So the tangent of 2 pi over 3 is negative root 3. Now we have something that's over 4. Over 4 means we're dealing with the 45-degree reference angle. 45-degree reference angle is a fairly straightforward coordinate because the 45-degree reference angle has the coordinate root 2, comma 2, comma, root 2, comma 2. So we know that's going to be the coordinate. What's going to change are the signs. So we need to locate where we are. Well, because we're over 4, this is going to be 4 pi over 4. That's pi. And 2 pi is going to be 8 pi over 4. Now, since we're trying to graph 5 pi over 4, that's one more than 4 pi. So we're in the third quadrant. Here is our 5 pi over 4. Now, in the third quadrant, both cosine and sine, or x and y's, are negative. So because it's a 45-degree angle, the coordinate point that we're dealing with is root 2 over 2, and they're both negative. So this distance right here is going to be negative root 2 over 2, and this distance right here is going to be negative root 2 over 2. So our coordinate is negative root 2 over 2, comma, negative root 2 over 2. Now it didn't ask for cosine or sine, it wants secant. Secant is the reciprocal of cosine. Since cosine is x, here's our x, we want the reciprocal of that. So the reciprocal of negative root 2 over 2 is 2 over negative root 2. Well, we need to rationalize, so we're going to multiply by root 2 over 2, root 2, sorry. So we have 2 root 2 over negative 2. Now our 2's can simplify, and our final answer is just negative root 2. So the secant of 5 pi over 4 is negative root 2. The last example we're going to do is on a quadrangle. So pi over 2 is 90 degrees. So here we are in our circle. This is pi over 2. The coordinate at pi over 2, or 90 degrees, is 0, 1. So we know that tangent is y divided by x. So we're going to need to take our y coordinate and our x coordinate and divide them. So we're going to have 1 divided by 0. Well, since 1 divided by 0 does not exist, then the tangent of pi over 2 is undefined. The video is now finished. Use this and the notes to complete your homework. I know you can do this. Feel free to watch some of the examples again to help you out.